Right, in this video we're going to be having a look at impulse over force, but before we do that, I'm just going to really quickly go over Newton's second law. So Newton's second law of motion is F equals ma. Acceleration, as we know, acceleration now is v minus u over t. So we can substitute that into this equation and it becomes F is equal to mv minus mu all over t. And this is actually the rate of change of momentum is actually equal to the force something experiences over time. So over the time it takes. So that is basically what force is. So F equals ma is actually from this equation over here. So what we're going to do is we're going to have a look at how this fits in with something called the impulse of a force. So Ft, if we were to bring t over across this side, it becomes Ft is actually equal to mv minus mu, and this here Ft, this notion, is actually equal to the impulse, something called the impulse of a force. So it's basically how long a force acts on an object for. So basically it's measured, it's got two different units associated with it. The first unit is actually Newton meters, and the second one, mv minus mu, it's actually just the rate of change of momentum actually. So mv minus mu, so we've got mass times by meters per second. So we've got kilograms meters per second. So we can actually quote it in two different terms here, and that there is our impulse, sometimes just called impulse on its own. So the way we look at this, or the way we can get it out of a graph, so most of the time these questions are given to you on a graph and you basically need to get all the information from it. So you've got force and you've got time and you've got something like this. So you've got force, time, and you've got the area over here. So this area is actually equal to the change of momentum. So that's what that area is equal to, the change of momentum itself, and that's only because this area is equal to Ft, and that is the impulse of the force as well. So that is equal to the impulse of force. Yeah, so the change of momentum, mv minus mu, is equal to the impulse of the force. So momentum itself, as we know, is given by the equation mv, and the change of momentum, so when you're going from one type of momentum to another, is given by mv minus mu. So do be wary of that, and that there is also the impulse of the force.